What is going on, everyone? In this video we'll be taking a look at the supervised machine learning algorithm called k-nearest neighbors. K-nearest neighbors is non-parametric, which means that it does not make any assumptions about the data. So as we'll see later, it is just computing the distance between data points, so it's irrelevant what the actual data consists of. And it is also lazy, which means that there is no training phase. So again, as we'll see, unlike neural networks that you'll train, the KNN algorithm just needs to have data present. And so later in this video, we'll be taking a look at an example at how to use KNN to categorize tumors. So, and in that example, we'll be using the area as well as I believe the density it was. But again, these features or attributes of the tumor doesn't really matter. I'm just using it for the sake of the example. And so the data set basically categorizes tumors as malignant or benign. So let's say that we had some tumors over here and these are malignant, and then we had some tumors over here, and let's say these are benign. Okay, so the way k-nearest neighbors works is whenever we introduce a new data point, so let's say we have a data point right here, the k refers to a number of your choice, so a constant. So for our example, we'll pick 5. So we are going to look at the 5 nearest neighbors to our new data point, and we're going to use the Euclidean distance. For those of you who don't remember what that is, so let's say we had 2 points here. Okay, this would be x1, this would be x2, this would be y1, and this would be y2. So the distance here would be the hypotenuse of this triangle right here. And so to compute the distance, we are using the Pythagorean theorem, and essentially we just get x2 minus x1 squared plus y2 minus y1 squared, and then we square root that. So anyways, let's say that we computed the Euclidean distance for the data points and we found that these 5 were the closest. So what we do is we tally up the data points for each of the groups. So malignant we have 2, and then for benign we have 3, and we end up taking the highest values. So since we have 3 benign, this data point right here will be categorized as benign. So I'm gonna pause the video here, and then when I come back we'll go through an example in Python. So as always, we're gonna want to start off by importing the required libraries. And so we'll import numpy as np, pandas as pd. We're going to import the confusion matrix because this is a classification problem. We are going to import the load breast cancer function from the scikit-learn datasets module. we are going to import the k-neighbor is classifier from the scikit-learn neighbors module. And then we're also going to import the train test split. And finally, we're going to import the label binarizer from the pre-processing module. Import. All right. And so to load our data, we can do cancer, like so. I probably misspelled something. It's from scikit-learn neighbors, import k neighbors classify. Yeah, there you go. All right. So if I were to print that, I know it's a bit hard to see. Yeah, I'll just wait. So we're going to create a pandas data frame, and we are going to pass in the breast cancer data. And for the columns, we're going to use the breast cancer feature names. And if I print X here, feature names. All right, so we have a table. I think it's something like, 30 features, so quite a lot. So we have things like the mean radius of the tumor, the mean area, the smoothness, the compactness, things of that nature. And there's a whole bunch more. So normally we would compute the correlations for each of these and then select the ones that have the greatest impact on whether the tumor should be categorized as benign or malignant. But for the sake of simplicity, I'm just going to pick 2 at random. But anyways, so the 2 I'm going to pick is the mean area and the mean compactness. And to do that, we do a double array here, and then we do mean area, and then mean compactness. So then if I printed X again, we would just have these 2. So the next thing we're going to do is we're going to import the categorical data and use the from codes. Oh, my bad. Breast cancer dot target, and then breast cancer target names. So if I were to print Y, we would get whether it were malignant or benign. But again, models don't work well with categorical data, and so what we're going to do is we're going to encode these using the label binarizer, and essentially we're going to represent malignant as a 0 and then benign as a 1. And so to do that, we do binarizer equals label binarizer, and then the encoded Y is going to be binarizer dot fit underscore transform. We're going to pass in Y, and then if we take a look at the new Y, you can see here now that I guess it's using 1 for malignant and then 0 for benign or something like that. Anyways, doesn't really matter too much. So that's good there. So again, the point of machine learning models is always to predict new data. And so we're going to separate our data set into a training set and a test set, and we'll use the test set to determine how accurate our model is. And so to do that, we'll do train X, test X, and then train Y, test Y is equal to the train test split. And we'll pass in X, the encoded Y, and then the random state again. This doesn't really matter so much, it's just for the sake of consistency, so you get the same results as me. And then we are going to initialize our algorithm. So we're going to use the k-neighbors classifier here. And then by default, it uses 5 neighbors, but I'll just specify it explicitly. And it doesn't actually use the Euclidean distance by default, so we're also going to have to specify that. Like so. Alright, so now we will fit our data, and again, for KNN, it's not really so much training, but anyways. So there you go. Now we need to get it to predict new incoming data, and so we're going to call the predict method, and we are going to pass it in our test or our X values from the test set, and we will call this KNN test predictions. So, and last but not least, we will use the confusion matrix to see the accuracy of our model. And so we're going to pass in test Y, and then we're also going to pass in the predictions we made. So these are the actual values, and then these are the predictions, and we get something like this. So for the confusion matrix, essentially the things on the diagonal are correct, and then on this diagonal they're wrong. So in the top left corner, this is you know, whether it predicted it was malignant and it turned out it was actually malignant, and then here is when it predicted it was benign and it was actually benign, and then here we have some false positives and some false negatives. And so if I were to compute the accuracy real quick, we would get roughly 79%. So thank you for watching. If you have any questions, let me know in the comments. And as always, I'll upload the code to GitHub.